So we are back with a third Rail M1b, and now I'm in my workshop. I have it set up here on my test rig, which is just a chunk of tubular track with some jack blocks. And I just got this nice old 4090 transformer, the 90 watt version that was made in Michigan, probably like in the early 70s. I think this one was dated 73. It's a replacement for my CW80, which died just out of the blue. It was hooked up to my car shop project for just the LED lights, and it decided to quit. So I went on eBay and I found this nice example of a perfect working vintage transformer, and it's nice and quiet. Now you don't have to hear that fan noise. One of the neat features of EOB was the ability to change chuff rates on the fly. There was a couple ways you could set up the chuff if you were doing your own DIY install. Like you could use the existing cherry switch or install your own, or you know, a magnet and reed switches. But if you use the flywheel encoder for chuff input, you had the ability to kind of tune the chuff input and also to have this selectable chuff rate feature. So during an install, you would take care to set up the initial chuff by punching in a code and, you know, running the drivers a revolution, and you would try to just tune that number so that you were triggering every 360 degrees, plus or minus a few degrees, you know, because of mechanical slop in the drivetrain and stuff. But I believe most of the OEM installs would have used the encoder, so you had this nice feature. So what I'll do is I'll turn up the sound a little bit and hopefully you'll hear me, but I'll demo what this feature looks like in operation and sounds like. And right now it's set for one chuff, and I'm in the 128 step speed mode. So if I hit the boost button, we'll start rolling out at speed step 1. So let's turn up the sound, and then I'll just get it rolling here. And you'll see we're in one truff mode right now. We're triggering at about 12 o'clock. You can see that. Funny thing is, if I stop at about 6 o'clock and like reverse or whatever, I'll keep going, you'll see the initial chuff gets triggered wherever you stop, basically. But anyway, to change the rate on the fly is kind of neat. Hit aux1 twice, then 5. You'll get an immediate change in the chuff rate, and you'll also get like a whistle blast to kind of tell you what your chuff rate is. So let's do it. I'll hit aux1 twice and 5. Got 2 whistle blasts, and now we're in 2 chuff mode. Hit it again. Now we're in 4 chuff mode. So it's kind of cool, you know, pretty unique feature, and kind of fun to play with, I guess. But to put it in one-step mode, it was kind of a nice way to see if your initial chuff was set up correctly. So if you're having trouble with the 4 chuff trigger, you can then tune your initial chuff input code or whatever. But that's it. Here's a nice little demonstration on the Sprung drivers, which makes these engines so nice. So you can see if I just push up on one of these drivers, you can see those segmented rods move up and down too. It's kind of neat. I will be pulling the LEDs out of these class lamps. I'm just not a big fan of that giant cable there coming out of the smoke box. It's just, I don't know, it's just so brutal looking or something. So I'll be pulling those, and I'll figure out a way to fill those holes in the smoke box there. Other than that, though, I mean, it's such a nicely detailed engine. Here's a peek inside the cab to see the nice backhead detail they put in here. So I'd mentioned I had some power pickup issues with this M1b, and over the years I had the same issues with the M1a, and I just kept kind of blowing it off. I would run the engine for a bit, maybe I'd get a couple nights out of it, and then the rollers would just get so dirty it would just stall all over the place, and I just kind of blew it off because I have so much other stuff I can run. But when I got this M1b and was doing the exact same thing right out of the box, I was like, it's time to figure out what's going on. So, I had my Fluke 87. I was continuity checking everything, checking all the wiring. Everything was perfect. And I got to the point where I decided, well, let me change the rollers out. I've got a ton in my stash. And I immediately got better performance out of the engine. It acted normally. I could crawl over my number 5 switches. I could crawl, anywhere on the layout. Even at speed, these things tended to load up the rollers and just conk out at speed, and that was driving me nuts. So once I figured that out, I decided, let me take a look at these third rail rollers a little bit more. And, there's nothing special about them. They're a little unique in their footprint that they've got these, like, you see the little tabs over here. That's kind of like an anti-rotate tab. And, they're kind of a long arm version, even on the tender, and that's fine, And there's nothing special about them. They go through these 2mm screws to these ring terminals, and that's the power pickups. And they're soldered under here by inside the frame, and you can actually see one of the pulleys for the quiet drive system there. And so to really replace these rollers would require so many mods, and I just thought, well, let me give this one more shot. Let me see if I can correct what I think is actually wrong with these. As far as them being a poor current path. So, if you look, there's a pickup roller here, and it's kind of oblong shape, and I don't really like these a whole lot. I kind of feel like they give you like the most minimal contact patch. But, these things have to roll on this rivet, onto the arm, and then there's another rivet here for the spring. And, these springs are fine. That's enough tension there. And then, they go through the ring terminal, whatever. But I thought, the easiest thing to try to correct on here is to make maybe a jumper wire so we're not flowing current, through this pivot point. Maybe that's the weakness. So I just decided on a whim just to try putting some solder braid from the base to this arm. And if you can see the solder joint under there, I had to turn my Hacko up to like 900 degrees, and I did all of the rollers. I did the 2 on both engines and the 1 on the tender for each. And wouldn't you know it, man, it fixed everything up. And man, I was so stoked because, like I said, I had perfectly good working EOB. I didn't want to change it out. I didn't want to spend the extra cheddar on the electric railroad stuff, as nice as it is. But so yeah, now these engines perform like all my other third rails. They crawl through the switches. They crawl anywhere. They operate normally at speed, and I think we're good to go. So I think if I ever run into this issue again, I'm just gonna try my little solder braid trick. This is like what, 3 cents worth of stuff, kicking around my workshop. So pretty cool.